example, and that will be created from scratch. Okay, right from scratch. How do we create such a project? How do we create SCADA screens or all those things will be covered in the end. So that is how this will be. The whole thing will be tuned up. Okay. So now let us continue from where we left yesterday. So we saw yesterday our I don't know. I think some people missed yesterday. Whatever it is, you can always come back. I did not show you one part of the plant yesterday for this. The this paving tile the AAC, aerated autoclave plant. So that is green separation. So we do a very special work. For this we are going to come when we talk of servo drives. Okay, when we talk of servo drive, we try to cover the green separation, which is a very interesting process, but very difficult to achieve. There are not many people have succeeded in doing this. What do we do after autoclaving? Once it comes out of the steam curing, see these lines, they are basically cut. They are cut by wires. Yesterday you saw the wire cutting. Then what will happen if you don't separate them? See, like they are separated now. In this video, you can see they are all separated. Otherwise, they get merged. So, if with merging, if you do the autoclaving, then they get bonded. So it is very difficult to separate them. Then you will have to hammer it. And once you hammer, gone. A lot of your blocks are in the same shape. So basically what we do, we separate them at the green stage. That means they still when they are wet, still when they are very very soft. At that stage, we separate them. So that is what we call a green separator, where we use all types of very advanced mechanisms like ball screws, lead screws, okay, and then servo drives. So a lot of these things are done in the green separation. I will show you probably when we talk of servo drives. Till then we will keep it. Otherwise, you have any doubts on like somebody asked yesterday some question, you can ask me. There is no problem. So you can go ahead and ask any questions if you feel. See, this is the green separation. Okay, so what do those see? The blocks are now, you can see they are already merged. You cannot see now this line is not at all visible. Okay, after cutting, what will happen? Because it's very heavy, they get bonded. Now this is a machine where we separate them. Okay, so this will come, stand up here, then see here. Now this line is faintly visible. So now this is what this machine does. It comes here, exactly locates this gap, engages, then separates. Okay, so this is what is a green separation. So see now, the moment it engages, you got a gap. You just create a small 1 millimeter gap. Now block is, as you can see, it's still a wet block. If you just touch it, it will break. So at this stage, we separate them. So by using a very sophisticated mechanism. Why we have to go for servo drives only for this? This is something that I will talk when we talk electrical engineering. See, we separate them. So these are some of the very critical operations we do. Anyway, this is a very long video, so we do not wish to get into all the details at this stage. So today we show some videos. Then tomorrow onwards we start mechanical engineering. Next class onwards, then electrical instrumentation, like that, one by one. One more video I would like to show you, since there are a lot of electrical people in this batch. See, this is our Singapore project. We executed a project in Singapore. Okay, so this is called, there is an island called Pulau Ubin. So this is in the south of Singapore. Okay, so this is very close to Changi Airport. And this is a very beautiful tourist island. Okay, so what did we do here? See, there are a lot of hotels on this tourist island like this. These are all the different hotels on the tourist island. So this island, there is, everybody has to pedal. Everybody has to go through a cycle. Basically, a lot of cycles are kept here. You can see all the cycles. Or you come down on a boat in a jetty, park your boats or whatever, take a bicycle and go around. Okay, so all the because there is only the other means of transport available, like this car and all, they have kept only for shifting the luggage, material, or maybe for handicapped people and things like that. Otherwise, everybody has to either walk or go by a bicycle. So this is what exactly is our project. In this, what is the automation we have done is basically we call hybrid generation. Okay, so this one of our power plant is inside this room. Okay, so what exactly we do? This is a tropical country. Singapore is a tropical country where there's a very bright sunshine. Okay, so what will happen? This sunshine is utilized to generate electricity. So what is our project in this year is, of course, there is no wind. Wind is removed. But our panel has a provision. So diesel engine and solar is used presently to give electricity to the entire island. This island doesn't have a grid connection. That means there is no electrical power given by the government. There is no grid connection to this island. So what is the part of automation? So here we have used this is our panel. This is what we exported. So we use a PLC here, and these are all front-end converters. This is more a power electronics project. If somebody is interested, because I'm not going to cover, the whole crux of this program is to understand automation. So we are not going to cover power electronics in detail unless somebody is interested. So what do we do? So this controller, what exactly it does? See, for example, I will give an example. See, in the morning, 9 o'clock, sunshine is very bright. Because this is a tropical island. No? Sunshine is very bright, and there is a good amount of electricity generated from solar. But the tourists have not come to the island because these boats start only by 7:30 or 8 or something. Then the people have to take this boat, and they are tourists, no, basically tourists. This is how the boat looks like inside. So we take a boat and go back. Every day we have to go to this island only by boat like this. So then what will happen? Once the students, so at the time, a lot of electricity is generated, but there are no takers. Okay, so what do we do? At the time, we pump the water automatically. We pump the water and switch on the ice vending machines. A lot of these activities, which can be done anytime, will be switched on automatically by our system. So that means there is electricity available, and there is no load. We try to use it. That is what this flow does. So this flow switches on all this. There are, by the way, this is not the only location. There are about 4 locations. We generate 800 kilowatt of power. 800 kilowatt is a lot of power. We generate about 3 megawatt power from the renewable energy. So then what will happen? So once the tourist starts coming to the island, and tourists are coming to the, like somewhere around 12 o'clock in the afternoon, everybody rushes to the restaurant to eat, okay, to have their lunch. At the time, there is going to be huge demand for air conditioners. So all those things will be switched on. Almost everything will be switched on at the time. At the time, what do? We switch on, because whatever is generated is not sufficient enough. Whatever is given from the renewable energy will not be enough to meet the load. Automatically, we switch on the engine, and we run the engine at different speed, right, from 3 RPM to 3000 RPM. So automatically, our controller changes the speed depending on the load. The whole purpose of changing the speed is to save diesel. Okay. So if you run at different speed, whatever is required speed, at that time, you consume only little diesel, enough to meet the load demand. But in the process, we will be generating variable frequency. But what we need is a fixed frequency of 50 hertz, is it not, throughout the plant? So that's what we call DFIG. So I am not going to cover a lot of things on power electronics. Though I started my career from power electronics, I can answer a lot of your questions. But this present topic is not power electronics. So what do we call? We call doubly fed induction generator. What do? We take an induction generator, we inject the rotor, so that even though it is at a variable speed, it always generates constant 50 hertz at the stator terminal. That is what we call doubly fed induction generator. That means we excite the stator, we also excite the rotor. Okay, this is called, if you are interested to know more about this thing, you can always go to Google, and there are a lot of articles written by a lot of people, and lot of research is going on this subject in the renewable energy. So you can Google and get more information. If you want to know more about it, you can visit our factory sometime. So when I am there, if you visit, then I can give you more information. This is actually me. I don't know, many of you have not seen, especially dispatch people. So I myself sat on that island for a very long time, with me along with my engineers. Anyway, okay. So this is one interesting project. So then what do? By changing the speed, we can see this is our solar panel. So this is how we put the solar panel on top of our room, and our generators, they're all kept, all our panels are inside this room. Nothing should be visible. So we were told that nothing should be hanging from this building. Whatever you want to do, you do inside. So outside, it should look very clean. And all cables, fiber optic cables, are run below the underground. So nothing is visible, because a lot of birds migrate into this island. A lot of from New Zealand and the nearby cold countries. A lot of birds see here. I didn't see any bird. I only saw the pictures. So a lot of these birds migrate into this island. So they don't want all these power lines hanging around and the birds getting stuck, and they don't want them to die. So that's why all electrical system related things are inside one building. So these are our panel, these are our generator. So solar is on the top of this building. So of course, solar is there in many places. Wherever there is a building, we have put one solar panel, and they're all wired underground with fiber optic and all that. So a lot of 5 countries participated in this project. It's a very actually very interesting project. All this SCADA data acquisition is all done by a company called Leonix from Thailand. And we supplied from India all the generators, panels, and other things, DFW fed induction generator and everything. Then the brain behind this is a professor from Perth University. So he is the brain behind this. Like lot of countries participated in this project. Okay, so we were one of the fortunate to get into this type of automation. Anyway, if somebody is interested, we will not be coming back to this topic again. If somebody is interested, we speak about this. I have videos of all these things of this project, how the contactors are switched on, what is, I have all the circuit diagrams of these things. You would like to know how it is doubly fed, how we inject the stator, so what is the mechanism. It's like all other details can be had in person. If somebody is interested, they can visit us and get this. Now, at this point of time, I will branch to another 2-3 more videos. Today, we are going to cover all these videos and stop, because we are not going to, of course, we will be getting to some of the videos in the later part, but as and when we approach, we will be coming to that particular portions. So I would like to show you one more video, which is also very important. I show this invariably in all our talk. Okay, so mainly because this has got a lot of things to learn and understand from this point of view. See, we are one of the pioneers. This is a Gujarat plant. After I came back from Singapore, these are the first projects we executed. Almost 20. Can you believe this whole? This is a 20 years old video. That's why it looks very shabby. Because at that time, when I started Venja Automation, and when we supplied automation to many of these plants, I never knew that one day I would be required to teach students. One day we will get into education thing, and we will be talking to students and trying to. Otherwise, we would have made a better videos. It doesn't matter. So here understanding the concept is more important. So what do we do here? We are one of the. These are called paver blocks. Okay, you would have seen on the footpath. Most of the footpaths and petrol pumps, you will see the zigzag pavers. The shape of this will be zigzag with the different colors and all that. Now, every year we make 2 to 3 plants like this. So this is our bread and butter. Okay, so if there is one big name for our company, it is in this field, in this paver manufacturing field. So what do? We have nothing to do with concrete. We handle the pallet. What we call, this is a pallet. Pallet means it's a metal plate. So this metal plate is 12 mm thick. So that means the weight of this pallet is 90 kgs. Okay. Now, there are 28 blocks, because this is the German machine. Of course, there are a lot of people in India also make this machine. However, those who have money, they import this machine from Germany, because the product quality, speed, a lot of these things can be achieved. However, there are many people who make these machines also in India. So what this does, it takes the concrete, then compresses them, compacts them, pushes onto this conveyor. So that's what this machine does. So now there are 28 blocks, 7 into 4. It's a matrix of 4 by 7. So each block is 5 kg. So 28 blocks into 5 is approximately 150 kg. You can say 30 into 5. You can just for the sake of calculation purpose. So about 150 kg of concrete and about 90 kg of pallet. Total weight of this is about 250 kg approximately. So every 12 seconds, this machine pushes 250 kgs. Okay, now I said before, ours is completely automated plant. Then what are these people doing? They are basically quality fellows. So randomly, they will take one block out of this. They will do the testing, because there are certain testing to be done for every batch. What is the strength, the green block strength? What is the strength achieved by a green block? Green means whatever is manufactured just now, which is very wet. Okay, very, very soft. That is called green block. Now, what is the strength of green block? After 1 day curing, what is the strength? After 2 days curing, what is the strength? All that, some quality related things they have to do. Now, this gentleman is a mechanical gentleman. He would have changed the mold. They make different shapes of product. Square, round, hexagon, zigzag, and so many types of products they make. So next time when I go to this plant, I have a schedule to go to this plant. They make hundreds of varieties of these products. I will take one video of that, and I will probably put it up for the next batches to come. So many types of products they make. Now, whenever they change the product, they have to change the mold. At that time, whether the blocks are coming in the center, some mechanical adjustment. So these are all people meant for such purpose. Otherwise, once everything is set, the plant runs smoothly without any intervention of any person. Now let us see the automation portion of this. Now these pallets are pushed every 12 seconds. Okay. Now you can see here. Now it activates a sensor here. You can keep observing here. Now a lot of things we have to learn from this video. Though it is a very old video, see it now. See it activates a sensor. We have made a similar plant in Bangalore now. So this plant is in Gujarat. I have taken a lot of people to this plant. Of course, same plant now, very almost same size. We have executed in Bangalore now. If somebody is interested, they can go. But it's little smaller plant. Actually, not this big a plant. But we will be executing one more very big plant in Todbalapur, much bigger than this. So we are. This is somehow our line of business. So we are experts in this. Lot of automation can be learned. So now, moment this sensor gets activated, what is this sensor? That is day after tomorrow's topic. Okay, that is the fourth class topic. So now, moment this sensor is activated, we have a hydraulic system. So we lift this pallet, go forward, drop, and come back. This is called a walking, something like walking floor conveyor. So this lifts up. You can see here, lift up, go forward, down, come back. You can see here. Now it will down. See, it will down, come back. So that means you shift one position of all these pallets. So what is this man doing? There are some bad blocks in the beginning stage. Due to alignment, there will be some blocks will get damaged. So this can be recycled. Material will not become waste. Actually, this is in the later part. This was also automated with the belt conveyor. But anyway, at this stage, so that means pallet with all these blocks keep coming. Okay, every 12 seconds. What do we do? One of the example we will be solving is this elevator. In our when we come to programming, this machine video will be shown again, and we will be writing a software for this with the motor, guitar, except this machine, because in my factory, we don't make machine. Okay. Now we started making, but we don't have this machine to show. Okay. Because as soon as this machine is ready, we dispatch it. We don't keep this machine because they're an expensive one. So, but we have a motor, we have sensor, we have everything, all the electrical system related to this. So what do? We elevate the pallet one by one up. See, the pallet comes and sits here, then we push it by one pitch. They're all angles. All these angles are on a chain. Their chain basically is the chain conveyor. So the chain will move up. That means once it rotates, this will go here, this will go here. They will all get shifted by one pitch. That's what you see. The pallet is elevated. Now see, already two are elevated. Now third one is coming. There's one more sensor here. You can see here. The small light will glow. So now this will come and hit this arm. Moment this fellow senses that there is a pallet, all the chain will move. That means this will go here, this will go here, they will all get shifted by one pitch. You can observe it now carefully. So moment the pallet comes, this downs and goes back. See, now this is all moving by one pitch. So this will move up by one pitch. Like this, 16 pallets will be stored. Because why I'm saying why we should do like this? Because see, every 12 seconds, this machine pushes a pallet. Now, if you try to store them horizontally, then you need a huge space. That's the reason we always go up, elevate. So now once all the 16 is filled up, now there is a sensor on the top. Now that sensor will tell this car, you go now, I am full. Now what is it you must observe here in this video is the interlocking. What do you mean by interlocking? Let me just go here. See, now like this one by one. Once it is full, this is a conveyor. This is another view. Previous view was this side. Now the video is from this side. So this is the conveyor which is pushing these pallets. Okay, now that will be disabled because once it is full, you can't keep on pushing the pallet. Okay, you can't because otherwise it will push the pallet out. So now whole thing is stopped. Stopped means only for a few seconds. Okay, the whole thing is stopped for a few seconds until this fellow goes inside, lifts by hydraulic. So this is a hydraulic mechanism. Entire things are lifted, then brought back. See, it comes back. Now all 16 pallets are lifted. Till then, observe here now. This is stationary because this fellow is inside. Till then, it is stationary. Moment this comes back here, one more sensor will be here. So the entire plant will be guided by sensors. Okay, those sensors are so crucial. Now next question will come. What happens if that sensor fails? We'll answer all those questions probably on day after tomorrow, maybe on Friday. Okay. So a lot of these things will be discussed. So now, moment this comes back and sits here, there will be a sensor that will tell now this fellow, okay, those are not physically connected because this sensor is not connected to your motors at all, but they give a signal to a PLC from whom they will get a command. So now, see, moment this comes back, immediately this starts. Immediately see. So no time is wasted. That is how automation is improves the productivity. That is how why people automate their plants, because human beings cannot every 16 pallets they cannot count. They can, but what will happen? You cannot put somebody for this mundane job, because each pallet takes 12 seconds. For 16 pallets, you hardly take about 3.5 minutes maximum. Within three and a half minutes, it gets full. So somebody cannot stand here for 3 minutes, watch this, do this, nothing. All completely mechanized. Now, one more important thing I would like to show you is now these cars are wireless. That means I don't have these wires at all. In the present plant that we are making, whatever we made in Bangalore plant, now this plant is also looking at that. They said I would like to come and visit that plant. My plant also to be made wireless. Why we are making wireless? This is a very old plant, almost 16, 17, I think 2005, if I remember right. This plant was commissioned in 2005. So 2005 to now, they must have changed this cable at least 5-6 times. Because what will happen, every time this cable expands, collapse, there is a life for this cable. Maybe about a year or 2 years. Now this cable, again a winding reeling drum, it winds, unwinds. All this cable needs maintenance because there is a brushes inside and all that. So moment it fails, the whole car will come to halt. So they periodically change the cable, which is expensive. So now we have done with a wireless Profinet. What is wireless Profinet? All those things will come when we talk of instrumentation. We'll try to understand. Okay, at this point of time, look at this car is going on a rail. This is a rail on which it is going. Now you can see a person standing here. Okay, so this man, see here. Now this is going at 120 meters per minute. It's going at such a great speed. Okay, now he's very comfortably because he has so much faith in automation, which we don't have, honestly. Okay, so we are very much scared. Honestly, we are telling you. So by the grace of God, we take so much of protection into system. That's why we don't have any accidents or we don't see, because all our automation is accident prone. So we have to be very careful when you automate. Because whatever fences, see, actually initially this plant was completely fenced. So there was a fence. Then people can't walk from here to here. They removed the fence. Now what we did, we put optical sensors. I'll come. When I talk to sensors, I'll show you what type of sensors we put all around. It's called optical light curtain. There is an infrared light curtain around this car. So if any person or any obstruction comes, this will come to halt immediately. So this is not going to crush anybody. So a lot of this protection we have to think. Protection is the topmost priority in automation. Okay, so unless you don't, not only protection for people, protection for equipment. No, these two should not clash. Suppose when you do here, see here. Now when this is going inside, this will also push us. Both the conveyor will collide. So a lot of protection is required for equipment as well as people. Anyway, this is a long video. Again, as I said, let me. We use varieties of sensors on this car. Okay, so now it will stop in front of whatever chamber you have entered. From this SCADA, they would have entered chamber number 5, position number 6, whatever, something. So it is up to them. So now this will come stand in front of chamber number 5, go inside. Inside there are 14 positions. Okay, so this will keep it in whatever position, maybe whatever is programmed. This itself will remember. So there is a PLC inside this box that will decide. Okay, now I have kept in 14. Next time I will come to 13. Next time 12, 11. So it will decrement on its own. So it doesn't. There is nobody to tell it that you go here, you come here. Once you set, so it will automatically go. Unless you want to change, because sometimes what will happen, chamber number 10 has got some product which needs to be dispatched immediately. At that time, they will intervene, change the number. They say, now instead of going to 5, go to 10 now, go fetch this, something like that. So it depends on them. So then it will, see, it came empty. It kept all the pallets. Now it will go to next chamber, take yesterday's production. Because so many chambers are there, the number of chambers, all this is a design parameter. We have designed such a way that you keep something today in this chamber, we are going to come to this chamber only tomorrow. Because it needs 24 hours of curing to handle it. So you must leave it alone. So just hot air will be circulated so that curing will happen. So this will go to next chamber, which and whatever it is going to fetch now was the product produced yesterday. So it kept in position number 12. Now here it will be position number 3. 14 will be 1. Position number 14 if you keep, then you take out from position number 1. If you keep it to 13, you take position number 2, like that. So it's all automatically done. Nobody, now it is much beautiful to see this type of cars because it is wireless. There is no wire also. In the next phase, we are trying to, but power is given by bus bars and all that. We will see. If somebody is interested, those who are in Bangalore can actually see this plant. It's a small plant. Bangalore plant is much smaller than this. But one more very big plant will be installing in another 6 months, which will be much biggest plant we would have done in our service. So okay, now this brought all the yesterday's production. See now in this first phase, cubing is manually done. What do you mean by cubing? Removal of these blocks. See this removal of blocks. I'll show you what it does. Now this car came and stopped in front of another equipment called lowerator. This is called elevator, where we were pushing the pallet up one by one. We pushed up to 16. Now this is ulta. This will do reverse. It will push the pallet down. Okay, that means the same motors will run in reverse. Now what do? We push the pallet out. Okay, one more will come down. I'll show you little ahead of this. See, let us go one by one. Let us finish this first. See here. Now see, one pallet is left. That's why this is waiting. Okay, so now when the last pallet is, see now these are all scraps, waste. So if some blocks are damaged, cracked, whatever it is up to quality people. So they do their work. So it does not bother about them. So now this is waiting. The car is waiting here because last pallet. See now last pallet is pulled. You can see now. Yes, now this conveyor is pulling the last pallet. Now once the last pallet is pulled, this will run and see if any pallets are left. If no pallets are left, then this fellow will be given a command. This machine will tell this machine, now I am free. Then there is a pallet with me, you come. So this fellow will go inside, place all the pallets, see, so automatically it will place. So no person doing any work here. So they're all guided by sensors. Okay, so they're all aided by different type of sensors. So they take their own decisions. So that is how the mechanization is completely done with this type of plant. Imagine this is almost 16, 17 years old plant. Okay, today's plants are much beautiful, but I still see this show this video. See now once it places, then one will see now it is going down. So you can see it is going down. It will pull one pallet. Every pallet are pulled. By the time it comes here, this will be full. That is how entire timing will be tuned in the process. That means moment, because no time should be wasted anywhere. Moment this fellow comes here, maybe one pallet are left or two pallet are left, or it may be full also. See, it is full. This case it is full. It simply goes inside, takes and comes out. Okay, so like this is how the whole process runs. Then one of the important point we have to observe here, in the first phase of automation, this cubing, that means lifting these blocks and stacking them like this, is totally manual. Okay, you can see so many 7-8 people are working on it. So they're also using what is called a grab. This yellow color equipment is called grab. So they use a pneumatic grab. So they don't touch the block. They engage the pneumatic cylinders. What is pneumatic and all we are going to talk maybe tomorrow. Tomorrow's topic will be pneumatic, hydraulics, a lot of these things. So what they do, they engage this and they lift it and stack it like this. Now this itself is so slow. Every 12 seconds that machine is capable of producing, but every 12 seconds we are not able to cube. Because our customer said, we don't have money now to invest. Let me start the plant. Whatever, half the speed or whatever, we'll start the plant. Now, in the next phase, this was automated. Look at the cubing now. It's so fast. We lift the ball. Why we turn and all those things is a separate. I don't think we should not get into such a detail. Now, what happened to those 8 people? They were not removed. Now, they became strapping people, quality. See, generally, it's a myth that, when you do automation, people will lose job. That is actually a myth. In my last 25 years of service, I have not seen anybody losing the job. Okay, so, but more production will come. You will require more people, but they will be deployed to different places. That means they will have to be reskilled. That means whatever work they were doing previously, that work will not be there anymore. So they will have to do a different work. See, now it takes stacks. Now production is very fast. So now this is waiting because pallet has not moved. So once the pallet moves, so this will go. So this keeps doing. So now new pallet will come with the blocks. This lift stack. So it will remember. This is a very intelligent equipment actually. Now, now it is too early to talk about this equipment. Once we finish all our electrical instrumentation, we will come back to this and see how this machine is designed. What all the type of sensors we use, encoders, so many types of sensors we use in this. So one of the very interesting machine. If time permits, we will see. We'll try to write a software for this, try to run this program, whatever it is. Now, it keeps stacking. That means this will raise height automatically. So now it remembers. Now I have kept 10 layer. Now whatever layer. Remember, go only that much, place and come. So very smoothly it does. So now what we'll do? Now let us see. Now we are keeping the last layer. Okay. Now what are these people? They are basically quality people. They are checking. Moment the block is kept, they will see any damages to the block. And if there is a damage, that has to be replaced now itself. Otherwise, what will happen after cubing? You can't remove the center block. You cannot even touch. So that's why these people are checking that. Then they do strapping. They put a bail putty so that it doesn't get dislodged. So now the last block is put. The moment the last block is put, it is sitting on another conveyor. This is called slat conveyor. Now this will go to next phase. Now this will start cubing from layer number 1. Starts cubing from like this. This cube will go out of the shed. Okay, this will go out of the shed. They will do the strapping. Okay, so this is what the people do. Once it goes out of the shed, they use a forklift. I'll just forward it a little. See, it comes out of the shed like this. So then a forklift will be used with a grab. So then it will be stacked into the yard. Because it is only 1 day old. No? It is only 1 day old. But minimum 7 days of curing is required. So they cure it in the yard. Cure means nothing. They don't do anything. They don't add any water or nothing, because the nature itself is it gets cured by the nature itself. Whatever is humidity available, because they use some chemicals inside. Add mixture and some chemicals will be used while making the mix. So that itself is good enough to attain the strength. So after 7 days, it will be dispatched to the site. So this is what is, see, look at the so much of production. So this is what is, this is how this plant works. A lot of things we learn in this plant. We learn pneumatics, hydraulics, different type of sensors, so different types of mechanisms we do. So let me finish one more video and wind up for today. Then tomorrow onwards, we are going to start the mechanical portion of this course. Okay, we talk of different type of conveyors, belt conveyors and flat conveyors, chain conveyors, roller conveyors. So different type of conveyors we see. Okay, so I don't want to show you only, I will show you one more. This is our Dubai project. So we have done a lot of exports actually. This is a company called Fujairah Steel Barrels. They are my very old customer and good friend of mine. Their owner is a very nice person and known to me very well. So even though there are hundreds of people in Dubai who do automation, they come to us only for because they have so much. Because automation business is actually a belief. You know, somebody may quote even higher, cheaper than us. Still, people come to us because they have to believe that these people can do the job. Okay, so let us see what do they make. This company called Al Fujairah Steel Barrels, they make these steel drums. Okay, they are one of the biggest exporters in Dubai. So they export to all countries in Middle East, like Saudi Arabia, Bahrain, Oman, and whatever countries in Middle East. They also export it to South Africa and Turkey and so many other countries nearby. So they are one of the very big exporters of these barrels. So they're always full. See, they make different colors. You can see here, red color, black color, blue color, whatever colors, green color. So they're all going for different customers. Now, this is one of the interesting automation I showed to many people. And we are going to come back to this when we talk of encoders. Okay, so how do we make this barrels? How do we make this? Let us an interesting process. Let us go through this short time. Maybe another. See, today I will. It's already 10:13 now. So another 2-3 videos I would like to show Foundry and other things. So today we are going to close these things. Then from tomorrow we'll start working on mechanical systems. In the next class, different type of conveyors and all that. So you may wonder why electrical people should know. See, this is important. If you when you want to seek jobs, okay, multidisciplinary approach is always appreciated. I'll tell you a small incident now. There was a student from one of the college. I don't want to mention college, don't bother. So he attended our workshop like this, about 5 days workshop or something we had done in their college. So we had discussed so many, we had shown videos and we had made them program with all the kids and other things. Now, what happened when when he went for an interview in one of the company, so they're also into automation. So they asked him so many questions about VFDs, servo drives, then all this chain conveyor, roller conveyor, and all. They are actually basically conveyor manufacturer. So this fellow was able to say, they said, are you a fresher or did you work anywhere? I said, no, sir. No, there was a course conducted in our college. So we learned so many things. So even if you reproduce 50% of whatever you are going to learn in this 1 month, that itself is good enough to fetch you jobs. I'm telling you, you will come back to us. Of course, many people have come back to us saying that, no, I went to so-and-so company for an interview and these were the questions and this is the answer I gave them. So based on that merit, we have got the job. So don't take things light. When I talk of mechanical engineering, it's a very simple thing. I'm not going to go deep into any subject. So you will, that knowledge may merit you a job. Okay, so with that intention, you see. Okay, now let us get back here. So what exactly is this fellow does? This is a cutting line. Okay, so what do? First, we take the sheet and cut them into length that is desired. So this is the encoder. Okay, so we use the encoder. What is encoder and all at this point of time? You don't know. Maybe by Friday we'll try to cover what is encoder. Friday or maybe next Monday. So this is a subject we'll be talking in one of the class. So what will happen? This encoder gives you pulses proportional to rotation. Okay, so now when the sheet is moving, it is touching a roller and it is pushing a roller. Now based on that, we decide and then we cut. Now this is called a looper. What do? We use, because sheet should not become tight, otherwise this will influence the length. So this is a looper control. So we call diameter computation. So depending on the sagness, we try to control the speed. We run it at different speed. So that looper control is something that I will describe to you. Maybe when I come to ultrasonic sensor, at that time we will come back to that looper control. So what do? We draw the sheet, cut them, perfect length. See, and they get stacked like this. So they get stacked like this continuously. So we cut the sheet like 1690 mm. Suppose you put 1690 mm, program it. This will draw 1690 mm, cut it. 1690 mm, cut it continuously. It keeps doing. Maybe 5 seconds, 6 seconds. I don't know what is the cycle time of this. So these are all very old projects we have done. Okay, but still they are very relevant for today, even today. So now length estimation is done by encoder. What is encoder? That will come later. Lot of type of sensors we use. Then this will be rolled into a shell like this. Then it will be welded. So this is a welding machine which will weld it and form a shell. Let us go a little forward. So a shell is formed. So after welding, this will form into a cylinder. It's called shell. That is called a shell. Now these are all hydraulic cylinders. Okay, so these are almost, this entire plant is hydraulic operated. So what do you mean by hydraulic? Say this is a cylinder which has got, you can see the pipeline, oil pipeline. Okay, now what will happen? This is a column. This is a very huge column which will be pushed by this cylinder. That means this flow of oil, you are using power of oil to push something. That is what is hydraulics. So see, now this is pushed. This column is pushed. You can see it's expanding. Now, what is the purpose? Purpose is there is a flanging tool. The tool will make these edges flanging. Flanging means opening up. Edges will be opened up. You can see here. See, you can see this column will be pushed forward, reverse. See, now once it pushes, that edges will become flanged. That means it becomes bent. So that is the purpose. So it will go back. The next will come. So every 7, 8 seconds, you keep doing. Then you would have seen. 1 minute. Let me just. Maybe I have to switch on the batteries. So you would have seen in many barrels, there will be an impression here. It's called beading. Okay, see here. Now this is again a hydraulic. See, it's such a big cylinder, column cylinder. So you push this fellow in and out. Here, this column will expand. See, this is made out of semicircles. Many. This is one piece. This is second piece, third piece. Now all the pieces will expand once it goes inside. It will go inside, expand, and make that impression. So see, this is that. Then this is another type of impression, corrugation. So again, this is hydraulic. You see hydraulic cylinder. This is hydraulic cylinder. It will push and it will retrieve. So it will push the tool, hydraulic tool. It will lift. So like this, so they keep doing. So one will come, it will do. So you can see the amount of production they make. Almost 8 to 9 seconds they'll produce one barrel. Okay, so maybe whatever 7, 8 seconds, whatever, some seconds. Let us not worry. So there is no person anywhere. So it keeps going. It keeps going. Only you will see person here is in the pressure testing. Okay, so this is sealing the end with all this. We call closures. The plates are put and they are sealed. Okay, so now they put some sealant here. That is only manual activity, so that when they put liquid, no leakage. Then this is one manual activity. pressure testing. Of course, he is also automated, but a man will be there always. So he will see, they put a compressed air inside to see any leakage. Okay, that leakage testing will be done here. So this is one manual activity. Here, one more manual activity for removal of these bunks, fitting the closures. Now, then they get painted. Interesting process is here. It goes into a oven, paint booth. It goes into a paint booth where different colors are painted here. So about 256 varieties of colors combinations can be made. Okay, so this is a paint booth where automatically nozzles switch on, switch off. So they paint this barrel different colors. We call recipe management. I'll tell you what is recipe management, maybe like later stage. A lot of software is built into this paint booth. Then it goes into the oven for drying. The paint gets dried and immediately they get dispatched. That's all. So either dispatched or stored or whatever, that is up to the company. So it is their wish. So our job ends once it is screen printed. I will just forward a little bit. See, once it comes out of the oven, so now it is already dry. It is completely dry. So we do what is called a screen printing, barcoding. All those things are done on this automatically. So then either they store it or dispatch it or whatever. It is all is up to them. So our job ends here. See here. Now whatever is the logo of the company will be screen printed. So then it will get either stored or directly it will be dispatched. Okay, so a lot of other types of sensors are also used in this plant. So this is actually a big plant in Dubai. Okay, a very big plant. A lot of German machines also comes in this plant. So a lot of this type of exports we have done. Okay. Now one more video I'd like to show, which is of foundry, which is something you must understand, all the belt conveyors. Okay, we will be talking about zero speed switches and several of these belt conveyor related things in the next portion. See what exactly we do. You know, you saw in the ball mill, a ball is used to crush all the material. Correct? I explained to you yesterday. So in the ball mill, where are ball mills are used? Ball mills are used in cement plant to powder the lime. Okay. Okay, lime will be available. Lime clinkers, they are called clinkers. They are available as a lump. Now nobody has time to sit and the powder it. So what do? We use a ball mill. In the ball mill, they will all be powdered. Okay. So I'll just show those. Maybe some people were not there yesterday. That's the reason I'm trying. So this is a ball mill in our Saudi plant. There we crush the sand actually. Basically, the ball mill. See, this is a ball mill. It rotates, and inside there will be balls, steel balls. So whatever material you are putting will get hammered. It's like somebody taking a hammer and hitting. So that will automatically happen. Then whatever is the material that we have put, they become totally paste or powder or whatever. Now these balls are in the process. Ball will also get consumed. Okay, so that means if you use 100 tons of cement, 1 ton ball will be consumed. These balls, after hammering, they also start getting powdered. Slowly this ball will shrink and it will become part of that material. So that means these balls are continuously required, and that is made in a foundry. Okay. Now foundry is also very interesting process. We will come back to little of this little later. A little part of this foundry we will be talking a little later. So what do? They melt the scrap. All types of iron will be melted, and they are going to put some. It's a composite material. Basically, you add some more minerals into this and melt it in arc furnace. So there are many arc furnaces. So once the steel is melted, they put it in a ladle. Okay, or this is called ladle, tundish, and so many names are given to this. So generally, it's a little dirty industry because you can't keep it very neat because of. You will understand once we understand the automation of this. So this is they pour the hot metal into this ladle. This is a furnace. Now this furnace is lifted. So furnace is now tilted to pour the hot metal into the ladle. Ladle is now standing on a crane. Okay, now this will tilt back once the complete hot metal is poured. Now second one is getting ready. Okay, you can see it is bubbling. So these are all furnaces. Basically furnaces. You melt the metal, composite metal. Now the furnace is collapsing back. Okay, now this ladle will go back and pour the hot metal into the mold. It is a sand. Basically, it's a sand. See here, you can see this is made out of sand. Okay, inside there is a small hole on the top where you put the molten metal. Inside there will be lot of cavities. which are round, different shapes, different size, cavities will be there. It's like a casting. Okay, different cavities will be there inside. Now you pour at one end, so metal will flow into all these cavities and it will take that shape. Now, this pouring is again manual. So people, I have not seen any plant where they automate this pouring because a lot of intricacies are there. So this will be generally poured, the hot metal will be poured into this. So what is automation is preparing the sand. The sand plant, let me finish the complete process of this. So now one of the very interesting process, okay, maybe punch out. So this sand comes from different places. There are more than 30, 40, this is our SCADA system for that plant. You can see there are so many belt conveyors. So many belt conveyors are there, so many. You can say BC30. That means before this there are 29 belt conveyors, but they are not used for automation. That's why we are not showing it. So 30 will feed the metal to 31, 31 will put it to 32. So BC means belt conveyor, BC 34. Then it will be elevated by a bucket elevator. So this is bucket elevator. That means all this belt will carry the sand. Then sand needs to be vertically lifted. Okay, how do you lift it vertically? That's where we use what's called a bucket elevator. How does a bucket elevator look like? Let me also show the bucket elevator is here. See, this is how a bucket elevator looks like. So it will be vertical like this. Okay, so whatever metal you put, that will all go to the top vertically. So how does a bucket elevator look like? This is how the bucket elevator looks like inside. It's a belt conveyor basically with buckets. Okay, now whatever metal goes into this bucket will go to the top, then it will throw it into another bin. So that is how these bucket elevators are made. So what do we do in this boundary? So that means there are a lot of process. Okay, the sand will come from this belt, it will go up, then it will fall into polygon screen where you remove all the dirt in that sand. A lot of some metal pieces or something will be there. So they have to be removed by a magnet and to be sieved. Then it will get stored into a hopper. Then again, any device which stores metal is called hopper. That's the terminology used in metal handling system. Then this will fall into another belt. From this belt again, bucket elevator. Lot of these belt conveyors are controlled from automation. Okay, sand plant is having so many belt conveyors and so many metal to be added, bentonite, this and all that. It's a batch mixing. Basically, you mix all this sand with all these chemicals. Then that sand will be used to make the mold. And in that mold, you pour the hot metal and all this. So there are a lot of intricacies for this belt conveyor programming. Use what is called a zero speed switch. I will explain you the zero speed switch here itself. What will happen? See, these belt conveyors are underground. Many of these belt conveyors are in the underground. Okay, so that means people are not seeing this belt conveyor. They come from kilometers. The sand comes from 3-4 kilometers. So okay, nobody will be there to watch all these belt conveyors, whether it is performing or not. But one strange thing will happen in a belt conveyor. What will happen? See here, this belt conveyor is carrying a sand. Let me go back here. See here, this belt conveyor. See now, this is a belt conveyor which is carrying a sand. So what will happen? Suppose if the sand becomes overloaded, okay, for some reason, belt will get stuck. This is a drive roller. We call this a drive roller because motor is coupled to this. Okay, so now this keeps rotating. See, this keeps rotating like this. Now, if the belt gets stuck, what will happen? This roller keeps rotating, but belt is stationary. At that time, there will be a friction between them, and this will catch fire because it's a rubber material, polybutyl material. It will catch fire. Now, nobody is there to watch. The moment it catches fire, immediately it will all surrounding equipment will get catch fire, and it becomes a huge hazard. Now to avoid such things, we use what is called a zero speed switch. Okay, what do we do for this idle roller? There will be idle rollers. See here, you can see these are all idle rollers of the belt conveyor. So they run only if the belt is moving. Otherwise, they don't run because they're not driven by a motor. See, these are all idle rollers. Now, for one of the idle rollers, we put a disc. If the disc is rotating continuously, then we put a sensor. If the sensor is becoming on and off continuously, that means this belt is moving physically. If that stops, immediately we stop all this belt. Then not only this belt, all the feeding belts. So there's a lot of logic in foundry. We will explain to you this portion we are going to cover because recently we made a belt conveyor in our own factory for training students. Now, see what happens. Suppose if this belt gets stuck, then we have to stop all the feeding belts. Otherwise, as such, this belt is overloaded with material. you keep feeding further, then it is no point. So stop this belt, stop all the feeding belts, but further belts can continue. Because whatever material has fallen onto this, that can continue, that can go to the hopper. That you should not stop. So now to understand that how this belt works and all those things. So we have made a belt conveyor which we gave it to a few colleges. Okay, if you see here, some of these things. See, this is the belt conveyor. See, this is the belt conveyor. We are giving it to a college where you can see a disc. So actually, motor is here. See, this is the motor. Motor is on the other end. Now, if I hold this belt, then this is like belt getting stuck immediately. This sensor, see, which you can see, the sensor is on. So this one equipment we have given it to many colleges. Lot of these things can be simulated. Of course, this is not our product. We don't want to make this small product. Whatever I am showing you is all, they're all quite big. Is it not? Because that is where our strength comes. Okay, our strength is in these things, making these big projects. So now a lot of these things are done in this, which we'll try to cover from tomorrow. Okay, so we will talk about, we try to cover foundry, we try to cover automotive plant, we try to cover all the paver making, bulk making, so many things. Actually, in fact, when we were commissioning this plant, it caught fire. One of the belt conveyor caught fire. You can see, if it catches fire, this is how it looks like. But only that belt conveyor caught fire. So that's why to avoid such accidents, we use some special. We will show you all these things when I come to programming. One of the programming is the zero speed switch. So at that time, whatever conveyor I showed you is there in our laboratory. Okay, I will show that to you, create that experiment. Physically, we will be seeing. Okay, so with this, we will be concluding for today's talk. So anybody has any questions, you can ask me.
This conference will now be recorded.
Okay, so what is the plan for the entire different type of sensors? So different types of mechanisms we do. So let me finish one more video, and this one equipment we have given it to many colleges. Lot of these things can be simulated. Of course, this is not our product. We don't want to make this small product. Whatever I am showing you is all, they're all quite big. Is it not? Because that is where our strength comes. Okay, our strength is in these things, making these big projects. So now a lot of these things are done in this, which we'll try to cover from tomorrow. Okay, so we will talk about, we try to cover foundry, we try to cover automotive plant, we try to cover all the paver making, bulk making, so many things. Actually, in fact, when we were commissioning this plant, it caught fire. Okay, now give me a minute. Let me also go for one more further continue, because we have time. So I do not wish to stop it here. So we will try to understand, but to keep one thing in mind, we are not going to go into deep into any. He says, I want 1,200 cubic meter liquid. Both of them get added in a mixer, and they, end of the day, investing 35 crores on this project, we should meet 1,200 cubic meter. Actually, would have got stabilized. Now, what you do? One car is good enough to design the speeds of all the cars. Once we get this timing diagram, then we know what is the speed at which this has to move. Now we take the worst case. That means this car has to, take a mold and push it into the last track here, and take one before and put it back here. That is the worst case scenario. So we calculate everything for worst case scenario. Okay, then from in that worst case scenario, this car is supposed to work for 4 minutes. So that is how all the speeds, the gearbox ratios, wheel diameters, all the mechanical parameters of this car will be designed now. So once we get this timing diagram, then each of these products will be designed. Same case with the crane. So I am taking one example. So see, this is crane. There is only one crane. I mean, that means there are 5-6 cranes, but for this operation, there is only one crane. Now this crane has to go lift the mold. Okay, then tilt it. Now see, it has lifted the mold. Go to the cutting line. Go to the another line. So it has to go to another line. Tilt. Okay, you may see some speeds very small in the beginning, because when we start the plant, we can't directly go to 4 minutes. We first attempt 10 minutes, then we bring it down to 8 minutes. Then we do now. Presently, after going here, we are tilting. Whereas actually, in the actual process now, while going only we tilt to save time. All these decisions are taken based on the timing diagram, because finally we have to achieve 1,200 cubic meter. That is the target. Now, in these 4 minutes, if I have to move this much distance, tilt, down, then that is how hydraulic cylinders, what is the size of the cylinder we have to go, what is the flow of the hydraulic, then hydraulic expert will come. So this is a consortium meeting, one mechanical engineer, one civil engineer for designing the layouts. Of course, civil will come little later. So, and one automation engineer, one hydraulics and pneumatics engineers, lot of us sit together and make this layout. So that is our first work. Our first work starts with making this layout. Okay. See here, this is layout of another plant. I'm just showing you how a layouts are prepared. Why we are involved, why electrical fellows or all the automation fellows have to be involved? Because this is where we decide whether it is possible. See, now it has happened in the past. In the past, it has happened. So these are the molds. It's a similar ASC plant, but this is a 2000 cubic meter plant. Now, if I have to go for 2000 cubic meter, I have to handle so many molds. All this area will be covered with molds for curing. We need to give an area for mold to cure. Now, when I have so many molds, if I put one crane will struggle to bring a mold from here, put it in. Imagine one crane, it has to take a wet mold, put it here, bring the dry mold. Second case, it has to go all the way to the left side. Bring a mold from here. Then we put a timing diagram. Then we one crane is not has to take a wet. That's why we have gone for 2 cranes. What you see here is the red lines are 2 cranes. Basically, crane number 1 and crane number 2. Now, half of the service will be of this area will be done by this crane. Half will be done this crane. So then comes the cutting line. This is the cutting machine line. So once this cured mold is put here, this goes for cutting. Then this is a green separation. Then heavy rollers. I will show you a video of all these heavy rollers. Then one transfer car here, one transfer car here. So one transfer car here. So all these layouts will be decided based on the production capacity. We are involved mainly because of timing. Because at the end of the day, see, that happened in the past. As I said, our machine builder or whoever, somebody makes a layout, then automation fellows are called at the last. After all motors, everything is finalized, then the automation fellows are called. Then once we call, then we say, now this motor is 3000 RPM motor. Now in order to meet the timing, this motor has to run like a rocket. It has to run at 10,000 RPM. That is how we come up with our, then we say, sir, this motor gearbox is not sufficient. It is very, very slow. Instead of 4 minutes, I'm taking 10 minutes now to complete the cycle time. So if we, instead of 4 minutes, we take 10 minutes, that means our production becomes half. So instead of 2000 cubic meter, we will be achieving only 1000 cubic meter. Now we have spent money for 2000 cubic meter and we will achieve half of the production. Then what is the point? So this used to happen in the past. Then people start blaming, no, automation is not very fast. What will I do if you give me a Jataka Gadi? If you give me a bicycle and expect me to go to moon, what magic automation fellows can do? So that means everything starts from mechanical design. Okay, that is the first step for automation. So finally, what will happen? Our customer decides all we along with our customer hydraulic person. So it's about 3 to 4 days. There is going to be a joint meeting. Then we have autoclave. All these are steam curing. Then the boiler fellow will come based on the volume of steam that we have to design. We have to design what is the tonnage of the boiler. We need so many tonnage of boiler. Whether we need a 10-ton boiler, 100-ton boiler, 200-ton boiler, all that decision will be taken along with the boiler manufacturer. So like this, because we have to automate the boiler also, automation fellow becomes a common factor. In all the discussion, automation fellow becomes a common factor. That is how we learn many things in automation. Okay, so we learn many things in automation mainly because we get involved with all the with all turbine fellows, boiler fellows, everywhere we are required. Okay, so what will happen? That joint meeting finally will produce an Excel sheet. That is how I will come. No, I will come to this Excel sheet probably tomorrow because this will be more electrical. Now, the purpose of this whole meeting is to get the details of sensors. Now, in this video we say now this car has to stop here. Okay, that means how many sensors will come? What is sensor? What all the type of sensors? That is going to be a discussion probably for Monday. Okay, so that means after 5 days we are going to come to this subject where electronics and instrumentation branch subject will be covered. At that time we talk of different sensors, the proximity sensor, limit switches, optical sensor. At that time we will be going to our laboratory where we have all these sensors and physically we can see. At this point of time, you think that some sensors are going to be used in the plant. Now, that is what the decision will be taken in the meeting itself, because that is where we come to picture. They say, So from this, now this car has to stop. This car has to stop at so many places, 1, 2, 3, 4, whatever number of places, and it has to align with the track. Now, for this align, we use a laser sensor. I told you on the first day. So, lot of this what we call equipment list will be done based on all these meetings. So that equipment list will be a simple Excel spreadsheet like this. That's all. One Excel spreadsheet will come out from this. So here, this is a batching plant. So what we do, we divide this plant into multiple sections. Okay, now this is the batching area. Top of mezzanine floor will be a batching plant where all this mixing, everything will take place. You must have seen in the video. This batching plant was on the top. See, this is not on. This is a batching plant where we get the powder, we get slurry, we mix up. This is on a mezzanine floor. Mezzanine floor, first floor, second floor. So it goes up because gravity, material has to flow through gravity. So that is how this is designed. Now below is car. Once you come to ground level, then you will see all the cars, cranes, and several of these equipment, tilting table, whatever, a lot of equipments are there, lots and lots of equipment. Because I have shown you only 10 minutes, 15 minutes of the video. Okay, but there are lots and lots of things that you can see. This process of AAC itself, I can explain you for 1 week at least. So much of information is available, but since we don't have time, so since we have to learn many things, so this is autoclave. This is the steam curing chamber. See, this is a car. So now I am standing on a mezzanine floor and I am taking this picture. So you will see a autoclave, and this is one more car here. One car, another crane, stacking crane. We call stacking crane. So this is how the entire plant layout will be made. Now see one more crane here. This has to be lifted. This is a tilting crane. So this crane will lift the mold, place it here. This is a cutting line where I used to make horizontal, vertical cutting. All these videos we saw first day in detail. So now once this layout and all these things are decided, then we estimate. I will also show you a software. In another 5 minutes, I will open a software and try to show you how we calculate all these ratings. Why we should go for 10 HP, why only 5 HP, how to calculate this rating. Just for 2-3 minutes, I'll show you. Because what will happen, if this hoist has to carry, say for example, the green hoist, see, this is also a crane, but this is a dry block crane. What it does, once the block is cured, it lifts all these blocks, separate them. It's called grab and shift crane. We call this, we give different names. This is before dispatch. See, now this is a cured block. Now what we do, you lift this block, place it on a table for strapping, then you separate them. See, it is separating automatically. 5 blocks, it is separating. A cube of 5 by 6, about 30 blocks are made separate. So this crane, see, now it will be strapped like this later, manually. So then it will be lifted by same crane and put it onto the, same equipment, same thing, strapped one will be lifted and put onto conveyor for dispatch. So now this will be outside the shed. So a chain conveyor will take it outside the shed, and then from the forklift, you lift it and stack it like this. See, they're all stacked for dispatch. So whatever it is now, there is a difference between this crane and the green handling crane. Because same size of blocks, once it is dry, the weight, this is a lightweight bricks, yesterday I told you why we are using fly ash, mainly because we want to reduce the weight of the bricks without sacrificing the strength. At the same time, your building will become lesser strength now. Building the columns and beams can be lower now because the weight of the building comes down. So dry block is very lightweight, whereas wet block is very heavy. So that means design of this crane is different from design of another crane. Now for a same type of crane, now this crane is handling the green block. See here, for example, this crane is still wet. It is handling the cake. So wherever we are handling the cake, which is green, the weights are very high, 8 tons, 9 tons. But the same will come to 1.5 tons, about 1/3 the weight gets reduced once it is autoclaved. Once it is put in the steam curing, the weight will come down. So lot of this calculation. Now to lift 8 tons in 1 minute, I need a different size of motor. Same 8 tons, if I have to lift in 4 seconds or 5 seconds, I need much powerful motor. So how do you calculate? That is where the timing diagram comes into picture. Now this whole thing should be done in 4 minutes. That means now I allot the time. 4 minutes means lifting 10 seconds, then go like this for 15 seconds, then drop it, tilt it. So many times I allot timing for each of them, which is a practicable timing. Just like that, allot a lot of time in the beginning operation. Then last operation you give only 2 seconds, 3 seconds. That's stupidity. That is where your experience comes into picture. Okay, having done many plants, so we know tilting can happen in 5 to 6 seconds because we are handling 8 tons mold and it cannot turn like a rocket. Okay, it is not possible. So we have to be practical and realistic. So in our calculation, we find within 4 minutes I can't do this, then I'll go for 2 cranes. Instead of 1 crane, I'll go for 2 cranes. So all these calculations we have done, then we allot a time for lifting, separation. This is called demolding activity. We have to separate this cake from the mold. So this bottom plate will become separate because this mold is 3 side one and separate on one side. So now all these calculations, there is a software. We make our own software for because if it is only some 5 motors, 10 motors, it's okay. I can take a calculator, sit down and calculate. But if I have to do for 400 to 400 motors, then I need some better tools to do all this. I will show you the tool, what tool we use to design all this. Now let me, because this mechanical will also go for tomorrow, maybe another half an hour. So 1.5 hours for mechanical, 1.5 hours for electrical, 1.5 hours for instrumentation. That is how we will divide our talk. So now all these chain conveyors, why we go for chain conveyor, why go for screw conveyor, what is the type of car, where we have to go for crane. So all these calculations are decided based on the complete productivity. Once those layout is finalized, so how many cranes will come, how many cars will come, then we use a special software. I will, I forgot to open that software. Let me, okay, so go back to this. The software will take time to open. So let me, okay. So let me open that software. Let it keep happening at the background. So meanwhile, let me continue our discussion. Okay. So this is what I'll come to this software a little later. Okay. So once we finalize this, now see, as I said, why I am involved in all this, because I need to know whether should I go for a servo motor, should I go for a stepper motor, should I go for induction motor? What is all that we have to do? See, I'll give you same example. Now here, okay, I think this sizing software, it will take a little time. So I think we'll continue for tomorrow. Or should I continue for some more time? Ravi Shankar sir, I think the sizing will take up tomorrow. So how to calculate different sizes of motor and all that will take up tomorrow.
Okay, sir. Okay, sir.
Okay. Or you want me to continue for 10 more minutes? I can. It's your call. Whatever you say, I will do.
Okay, sir. No problem. We'll continue tomorrow.
Okay.
First day. Tomorrow we'll continue the session.
Okay.
Thank
In
you
case
so much,
anybody
sir.
has any questions, they can ask me.
Yeah.
Anybody has any question?
Yeah. Request the all participants, please can chat the questions for chat box, or you can ask the
Now be
questions
recorded.
directly to resource person.
So,
Once I request to participant, please ask the questions. If you have any doubts? Okay, if no questions, we'll stop second session today. So we'll meet tomorrow at 10:15. Thank you. Thank you so much.
This conference is no longer being recorded.